We're starting with what's called the fundamental theorem of algebra. A guy named Carl Gauss back in the 1800s came up with this bad boy. And it says this: if p of x, so some polynomial, is a polynomial of degree n, okay, where n is greater than or equal to 1. So we're not going to have a negative, we're not going to have a 0 as our degree. Do you remember how you find the degree, first of all?
It's the exponent on the monomial.
The largest exponent, right? It's your largest exponent on any monomial in your polynomial that you're working with. So it says then p of x equals 0 has exactly n roots or n solutions, okay? And I told you this already, so this should not be new information to you because I did mention it when I was first teaching you about this stuff. I said, oh, by the way, we're going to talk about this as well. So if you look at this polynomial, can you tell me how many solutions you should get? 7, right? It is your largest degree. There would be 7 solutions here. How many solutions for x squared plus 3x minus 4 equals 0? 2. Okay. And we call them roots, or we call them solutions, or we call them zeros. They're all interchangeable here. When you do this, remember we've talked complex numbers, imaginary numbers, when that I comes into play, when you have a negative radical, those are complex answers. When you solve these and you get complex solutions, so when you get those imaginary numbers coming into play, those always come in pairs. So you will never get one imaginary solution and 2 real solutions, okay? Whenever there are complex answers, they always come in pairs because we have conjugates of each other, right? So if I have 2i, then the conjugate would be a negative 2i. In other words, if 1 minus 3i is an answer, then 1 plus 3i will also be an answer. You will always have the conjugate of whatever your first one was be an answer as well. So if 7i is an answer, then negative 7i is also an answer. So the conjugate will always be another answer to your polynomial solution. Okay, so what we do to solve a polynomial equation is we set it equal to 0, p of x equals 0, and then we factor it to find our solutions. If you can't factor it, then you use the quadratic formula. But your first step should be try to factor it first because factoring is a lot simpler than having to plug into the quadratic, okay? So this should not feel terribly new to you. You've done these before. You just haven't maybe thought of it like this, but we did these last week already. Okay, so if we're going to solve, look at this first letter A. First of all, you should rewrite so that it's equal to 0, right? That was your first step right here, right? P of x equal to 0. So how would you rewrite this one? 2x to the third minus 5x squared plus or minus? Minus 3x. We got to take that 3x away from that right side. So this is what we're actually going to be solving. How many answers should you get here? 3. You should get 3 solutions because of this little 3 right here. Okay, so you should get 3 solutions to this. Now it says factor it if you can. What do you do first to try to factor this? Take out an x. Yeah, we're going to factor out our GCF, which in this case is an x. So if I factor out an x, I have 2x squared minus 5x minus 3 equals 0. Now what? What's your next step? Star method. Yeah, we're going to keep factoring using the star method. So up top, it's negative 3 times 2, so negative 6. On bottom, it's a negative 5. My a term is 2. Okay, so what can I multiply to get a negative 6 that I can add to get a negative 5?
3 and 2. Or
Not negative 3, negative 2. 6 and 5 is always the one that people get mixed up on because there's too many options here.
Oh.
Negative 6 and a positive 1, right? So if we reduce that 2 over negative 6, that would be 1 over negative 3. Okay, so now I have, don't forget about your little friend out in front here, the x. X times x minus 3 times 2x plus 1. Right, so I took this, I took that, and I took my x out in front and rewrote it. Can you tell me what your zeros are? What are your solutions here? What would it be for this guy? To make him 0. 0, right? You get a 0 for that one. What if we wanted to make x minus 3 equal to 0?
X equals 3.
A positive 3, yep. And then 2x plus 1? A negative 1/2. You would take away the 1 and then divide by 2. So you get a negative 1/2, 0, and 3. Okay? Does that answer make sense with what we started with? Yeah, we got 3 solutions, right? Those are our 3 solutions. Is that going to be a hand up? No? Okay. Questions on that? Okay, letter B here then. First step in solving this is to set it equal to 0. So we're going to rearrange a little bit. This would be x to the 5th. What's going to come next? Minus 5x to the 4th. Yeah, we're going to move this over. Minus 5x to the 4th. And then what?
So 6x to the third.
Plus 6x to the 3rd. Yeah, we got to move this 2x to the 3rd over here, but we have an x to the 3rd already. So add those together. You get plus 6x to the 3rd equals 0. How many solutions should you get?
5.
You should get 5 solutions because we've got this 5 right here. Okay, so what's your first step?
Factor if you can.
Factor what?
X cubed.
You can take an x cubed out of this. So if I take out an x cubed, I'm left with x squared minus 5x plus 6 equals 0. Then what? Star method, yeah. So if we do our star here, your a term is 1. What can you multiply to get 6 that you can add to get negative 5? Is that 6 and 5 again? Negative 2, negative 3. So we have x cubed times x minus 2 for this guy times x minus 3 for this guy equals 0. What are your zeros? Do you remember how you write this?
Yeah.
Multiplicity.
Multiplicity. Do you have to? Is that what you said?
Yeah, just like write 3 zeros, it's easier.
No.
Yeah, I don't think so. I think you have to write multiplicity. Just to acknowledge that we know they're the same thing. So 0 with a multiplicity of 3. A positive 2, right? For this one here, x minus 2 would have to be a positive 2 to make it 0. And a positive 3. So 0 with a multiplicity of 3, 2, and 3. Questions on that? That doesn't really feel new, right? We've done that. This next part is a little bit new, but I think you'll find it's not terribly more difficult than what we've done already. Okay, so quartics. So far we've done quadratics a ton, right? You know how to factor, God bless you. You know how to factor a quadratic where it's x squared plus 2x plus whatever. Now you're going to see some that are quartics where you can't factor out an x or an x squared or an x cubed, but you have this x to the 4th out in front. Notice this doesn't have any x with it, so we can't factor out any of those x's, okay? When you get a quartic, you should get 4 answers. Your options are you could get 4 real solutions, that's option 1. You could get 4 complex solutions where all of your answers have I involved in them. Or you could get 2 real solutions and 2 that are complex. You cannot do 3 in 1 because if you have your imaginary, it has to have the conjugate with it, okay? So with Cortex, you're either going to get 4 real, 4 complex, or 2 of each, 2 real, 2 complex, okay? So here's what you do with this. Basically, and maybe you want to just make a note to yourself here so that you don't forget, you're just going to do star method with an x squared out in front is essentially what's happening here, okay? So you're still going to set this up using the star. You're going to ask yourself, what can I multiply to get a -4 that I can add to get a -3? My A term is 1. What 2 numbers would I get there? What can I multiply to get -4 that I can add to get -3?
-4 and 1.
-4, +1. Okay, so now here's where it's different. This is not x minus 4 because this front thing is an x to the 4th. So if I want to get x to the 4th, I have to multiply x squared times x squared, right? So now we're going to put that x squared out in front. So x squared minus 4, and then x squared plus 1 will be our factored form. But now the idea is solve. We want zeros, okay? So when we solve this, you're just going to set it up. X squared minus 4 equals 0, and x squared plus 1 equals 0, right? We want those 2 binomials to be equal to 0 because those will be our options for answers then. So how do I solve that first one? X squared minus 4 equals 0. Solve it. What do you do? Just add 4. So you get x squared equals 4. So what is x?
2.
Is it? Positive and -2. Yes, if I square root on both sides like this, it must be the positive or negative of that square root. So plus or minus 2. Is that a real solution or a complex solution? Real. The number 2 is a real number, right? Okay, now look at the second one. Subtract 1, and we get x squared equals -1. Take the square root of both sides, and you get x equals, don't forget your plus or minus what? What is the square root of -1? I. Yep, so x equals plus or minus I. So with this one, we got 2 real solutions and 2 complex solutions. Okay, we still got 4, but 2 are real, 2 are complex. Questions on that?
Is it so any negative that gets square rooted, the I is going to be like the positive version? Like if it's like negative 49I, then it'd be, or no, negative 49 square root, then it'd be 7I.
Yes, yep. I know, you kind of got to refresh on all these things, right? It's been a little while. Okay, I kind of want you just to try this one on your own. Why don't you do that? Try this. Same process. Set up star method. Set up your 2 binomials and then solve setting them equal to 0 and see what you get. I love it when I get to the bottom of my tea and it's all the honey that I put in first. So good. What'd you put on top here of your star? 36. 13 on bottom, right? Your A term is 1. So what two numbers did you use? 4 and 9. Okay, so now here's where it's different. What'd you write? X squared plus 4 and x squared plus 9 equals 0. Looking at it right now, if you're thinking forward, you might be able to tell me already. Can any of you tell me? 4 real, 4 complex, or 2 of each? Sean? 4 complex, right? If we're adding 4, we're going to have to subtract it, which is going to make it negative. And if that negative shows up, then when we square root, you're going to get a complex solution, okay? So if we simplify this, x squared plus 4 equals 0, and x squared plus 9 equals 0. We're going to take away the 4. So x squared equals negative 4. And then when we square root that, that becomes x equals, don't forget your plus or minus. What is the square root of negative 4 in simplest form? 2i. Plus or minus 2i. So there's 2 answers. Then over here, take away the 9. So x squared equals negative 9. Square root. So x equals plus or minus, what's that? 3i. So you got 4 solutions, but all 4 of them, because they all have the I, all 4 are complex solutions. Good on that? Doesn't feel terribly new, right? Just a little. Okay, and then this shouldn't feel new at all, really. One minor detail that we're going to do, but you have done this. So get out your graphing calculator. I'm going to put it up on the screen up here. And we're just going to talk through this again, do a little refresh. The one thing to look out for here, it says find your solutions, okay? You're basically doing the same process we did, was that last week that I showed you that? Or, well, the last week that I saw you. But notice in the notes, it says you might not find all the solutions because your graphing calculator doesn't find imaginary numbers for you when you're doing this stuff. So you're going to be solving them, but you might only find, one solution or, not necessarily every single one. So the steps are there. Put in the equation, set equal to 0, and then you'll set it up how you always do. Zoom 6, second trace 5, enter, enter, enter. And we're just finding the zeros, okay? We're not even finding the relative maximum, the relative minimum, any of that stuff. We are just finding zeros. So this should not be anything new for you. So you start by going to y equals, clear that out. We have, before that, we got to solve for 0. We got to set it equal to 0. So what is your equation you're going to plug in?
X cubed plus 3x squared minus x minus 3.
Minus x minus 3 equals 0. Yeah, so it's going to be x to the 3rd power. Remember, if you want to raise it to the 3rd power, you can either use this little caret or you can just go math 3. Cubes your thing. I like that one better because then you don't have to remember to arrow out. So x cubed plus 3x squared minus x minus 3. And hopefully you still have a y2 equals 0, but if you don't, put that one in also. How do you graph this? Zoom 6. Zoom 6. We'll give you that standard window. How many answers are we going to get right here? 3. You can see the 3 intersections between those 2 lines, right? So you're going to go second trace, which one? 5, the intersection. So second trace 5. If you just hit enter, enter, enter right now, it's going to choose one for you. Mine chose the middle one. I'm guessing yours probably did too. So you get x equals, that was -1. Okay, now do it again. Second trace 5, and now you need to arrow closer to one of the other ones. I'm going to go to the left. You may go to the right if you want. Arrow over, hit enter, 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 and you get -3. I'm going to do it one more time, going to the other one. Second, trace 5, arrow way to the right, and then enter, 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 and you get x equals 1. Okay, so those are your 3 solutions. We did get all of our solutions here. There wasn't a complex answer because it was an x to the 3rd, and we got 3 solutions. Okay, so we know there's no complex answer that's missing there. Chris, did you have a question?
I did, but it doesn't matter.
Okay. All right, letter B. You need to rearrange a little bit on that one. So 3x to the 3rd plus 12x squared minus 3x minus 12 equals 0. So go to your y equals again. 3x to the cube. I'm just going to insert. You are welcome to do this. If you go second and then the delete button is insert, you can just put a 3 there. And then if you arrow over, then you don't have to redo your cubing. I just think that's a lot easier. Same thing here. If you go second insert and hit a 1, and then I would arrow over and turn that into a 2 so that it gets rid of the 3 that's there. So 3x cubed plus 12x squared minus, if we keep going with this, insert in front of that x, second insert a 3, and then arrow over minus 12. You're welcome to do that every time. I don't know what you feel like is easier. They're probably about the same amount of work. So 3x cubed plus 12x squared minus 3x minus 12. Graph it by doing zoom 6. And then find your intersections. How do you find it? Second trace 5. Second trace 5. And then enter, enter, enter. We'll find one of them for you. Again, it found that first one at -1. So the one in the middle is what mine found first. Second, trace 5 again. And then arrow to the right or to the left. Up to you which way you want to go. Enter, enter, enter. And you get x equals 1. And then do it one more time. Second, trace 5. Go way to the left now. Enter, enter, enter. And you get -4. So -1, 1, and -4 should be your 3 zeros for that. Were there any complex solutions on this one?
Nope.
No, because our equation was x to the 3rd, so that means 3 solutions, and we found 3 solutions. So no complex with that. Questions on any of that?